In this video we're going to discuss a special case of factorising. It's known as the difference of two squares. So if we have x squared minus y squared, what we have is two square numbers being taken away. A difference is another name for take away. So you must have two squares and you must have a takeaway. And when you get that, you get a unique result, which is one bracket that's a takeaway and one that's an add. I'll just show you how that works using the face method that we've already covered. So there's our eyebrows, our nose and our mouth. And what we get is x times x, which is x squared, minus y times x, which is minus xy, plus y times x, which is plus xy, and minus y times y, which is minus y squared. You can see here that these cancel each other out. So what we end up with is x squared minus y squared, as in the bracket. So just to prove that to you, I'm going to show you what happens when you do it with actual numbers. Obviously you'd never do it with actual numbers, but I'll show you. So if we had 25 take away 16, we know that that equals 9. 25 take 16 is 9. But we're going to deal with this algebraically. So we have 25, which is 5 squared. We've got 5 squared minus 16, which is 4 squared. So what we have is 5 minus 4 times 5 plus 4. 5 minus 4 is 1. 5 plus 4 is 9. 1 times 9 is 9. Like I say, you would not do it with real numbers. So I'll show you it with an actual letter in there. I've shown you the simple one, x squared minus y squared. This time we'll do 121v squared minus 100w squared. For those of you who've learned your square numbers, you would know that 121 is 11 squared, v squared, and 100 is 10 squared, w squared. So what that gives us, if we remember our method here, is our numbers without the squares in two brackets, one positive, one negative. So we've got 11v plus 10w and 11v minus 10w. If you don't believe me, have a go at multiplying that back out. You'll get back to this. I'm going to show you another example. If we have 4a squared minus 1. 1 can also be written as 1 squared. So what we've got here is 2 squared a squared minus 1 squared. So we can write that as 2a plus 1, 2a minus 1. Doesn't matter what way round you put your brackets, you could put your minus first if you prefer to. And now I'm going to show you a harder example. If we have 10a squared minus 90b squared, What do we do there? We don't have squares. What we do have though is a common factor. So what you do first and always when you look at these is work out if there's a common factor before you attempt any factorising. So we have a common factor of 10, which gives us a squared minus 9b squared. And lo and behold, we've got a nice little square we can work with. So 9 is 3 squared, so 10 times a squared minus 3 squared b squared is what we're really dealing with. So we get our line 10a minus 3b, a plus 3b. I wrote it the other way around this time, it doesn't make a difference. Okay. And that is the difference of two squares.